All right, so in this lesson, we are going to calculate and interpret the lateral and total surface areas of triangular prisms. You know what? I will circle triangular prisms. So lateral and total surface area of triangular prisms. We're going to do this by combining areas of each face. Basically, remember that area is how many squares it takes to cover something up. And so what we're going to do is try to see how many squares it would take to cover up like an entire triangular prism. So example 1, we have the triangular prism, triangle base right here, triangle base right here. And you can just see it. It's a triangle that's pulled outward like this, right? So lateral face 1. Remember the lateral faces are everything except for the top and the bottom. So sometimes it's most useful to look at your bases first. So look at your bases. So I am actually going to underline this. So your triangular bases, this will be a base. And then this will be your other base. So they're both the same triangle, correct? So let's go ahead and draw that. And we can see that it's a right triangle. It's kind of hard to see on that black background, but it's a right triangle. Okay, or maybe I can make it look a tiny bit better. Okay, so to get the area of this, most of y'all like to use base times height divided by 2. So the base of this triangle is 4 centimeters. The height of this triangle is 3 centimeters. So 4 centimeters times 3 centimeters. I'll make that a little bit better. 4 centimeters times 3 centimeters. We could do tiny bit better. Then we're going to divide it by, oh my goodness, can't even get that right, times 3 centimeters. Divided by 2. So 4 centimeters times 3 centimeters is 12 centimeters squared, or 12 square centimeters, divided by 2. And then we end up with 6 square centimeters. And that is the area of our triangle. All right, so I'm going to put that in here since y'all are used to that. 6 centimeters squared. Okay, now the lateral faces. So the lateral faces are going to be everything except for the top and bottom. Actually, let's back up. The triangles are the bases. What I want you to understand is that these are like the top and the bottom. It's just been tipped over. Like it was sitting up here and then we like tipped it over and it fell over this triangular prism. So this triangular prism was tipped over. So these are actually like the top and the bottom. Maybe that was the top. And this is the bottom. It was just tipped over. So that means these are the lateral faces. Let's just pick the one in the back first. Well, I don't want to cover everything. Everything back here. Right? So green, that's obviously a rectangle. This rectangle is 11 long. Don't get fooled by this 5. This is the base of this. It's 11 centimeters. And the height of this rectangle is 3 centimeters. So base times height will give me an area of 33 centimeters squared. That is our area. That's how many squares it takes to cover the inside. Lateral face 2. Let's use blue. Let's use this bottom rectangle. Lateral face 2 is 11 centimeters long. by 4 centimeters. You can see it like this and this. If you prefer, I'm actually going to draw it like this instead. You can draw it the other way if you want, but I feel like most people probably see it better here. Here we go. And if we do it this way, that's 4 centimeters. And then by 11 centimeters. I think it's easier to see the 11 centimeters when you draw it this way. So based on its height, it's 44 square centimeters. Okay, and our last lateral face. I guess we can make this one pink. Now, this is the last one. It sort of goes, it's the largest looking rectangle in the diagram. I'm going to draw that. And we have 11 centimeters by, this is where the 5 centimeters comes in. So maybe I need to, I covered that up a little too much. There it is. Okay, so now I can see it better. So that is 11 centimeters by 5 centimeters, which gives me an area of 55 square centimeters. All right. So let's talk about the lateral. Remember, the lateral is everything except for the top and the bottom, the top and the bottom. So we're going to add these lateral faces, like these rectangles around it, basically. So let's do, well, I should probably underline this just for sake of consistency. Okay. So now our lateral surface area, everything except for the top and the bottom, all the areas except for the top and bottom. So we have 33 square centimeters plus 44 square centimeters plus 55 square centimeters. Remember, lateral is like the side without the top and the bottom, so we're leaving out the triangle on top and bottom. So this will give me a 66. I mean, I don't know why I said that. 77 centimeters squared. And we'll have to add 55 square centimeters. So 50 and 70 give me 120. 127. 127 plus 5 is 132. So I'm going to put equals 132 square centimeters. And that is the lateral surface area. Okay, so that's our lateral. That's everything except for the top and the bottom. Now we want to actually get the total, which would include the top and the bottom. So let's go ahead and, I don't know, I think we kind of ran out of colors here. So I might have to go back to, I just guess I keep yellow here. So I'm going to keep this, and I get 132 centimeters squared. I just need to add the top and the bottom. Now remember, there are 2 of these. So 6 centimeters and 6 centimeters squared, of course, 6 square centimeters and 6 square centimeters. So that's 12. 12 and 32 is 44. So 144. 144. Ooh, I'm running out of space here, so I'm going to write a little smaller. 144 square centimeters. That is our total surface area. Okay, so it would take 132 square centimeters. That means centimeter squares. to cover the lateral faces, just the lateral faces. To cover the lateral faces, and it would take 144 square centimeters to cover all of the triangular prism. We'll just put prism. You know what? Instead of prism, we're going to say it takes 144 square centimeters to cover all of the faces. All of the faces. So